We've come to the last quadrilateral we will study in this course, the kite. In the last video, we examined the properties of trapezoids and isosceles trapezoids. In this lesson, we will spend a little bit of time discussing the unique properties of kites. For a quadrilateral to be considered a kite, the shape must have precisely two pairs of congruent consecutive sides. Remember, consecutive means one after another, or next to. As you can see, there are no parallel sides in a kite. Kites are relatively simple shapes and can really only be distinguished from each other by the measures of their angles, which brings us to the next two theorems associated with kites. The first theorem states that for a quadrilateral to be considered a kite, there should be precisely one pair of congruent opposite angles. Specifically, those angles are the two angles in between each pair of non-congruent sides. If the shape did not have congruent angles here, the shape would no longer have two pairs of congruent consecutive sides and would not be considered a kite. The second theorem is similar to one of the rhombus theorems we saw previously, which stated that the diagonals form a perpendicular intersection. The same can be said of kites. If the shape did not have a perpendicular intersection, there would likewise not be two pairs of congruent consecutive sides. To avoid confusion, I should note that all kites have perpendicular diagonals, but not all quadrilaterals with perpendicular diagonals are kites. Obviously, rhombi have perpendicular diagonals, but are not kites by definition. Rhombi are parallelograms, while kites are not. This is the main difference between the two, despite their perpendicular diagonals. And that about wraps it up for kite theorems. These two theorems are the conditions we will use to determine if quadrilaterals are kites. Let's take a look at a couple of examples. Example number 1. The first shape we will look at has some information regarding the length of its sides. Two sides both have a length of 6 units, while the other two sides have a length of 3 units. Because the lengths are the same with these pairs of sides, that means they are congruent line segments. The sides that are congruent with each other are also consecutive. With this information, we can conclude that this shape must be a kite. Example number 2. Our second shape has a 90-degree intersection. This means that the intersection is perpendicular. There does not seem to be a parallel relationship between the opposite sides of our quadrilateral, so this shape cannot be a rhombus. This allows us to safely assume that the shape is a kite, since the information we have satisfies theorem number 2. Like always, we will finish by discussing how to calculate the area of a kite. Remember earlier how we saw a similarity in diagonals between the kite and the rhombus? As it turns out, both shapes have a formula for calculating area that involves their diagonals. Looking at our kite, if we make copies of each triangular piece formed by the diagonals and rearrange each piece like so, we form a rectangle that is one diagonal long and another diagonal wide. But remember, this rectangle took twice as much kite to construct, so we can cut the rectangle's area in half to calculate the proper area of a single kite. The formula for the area of a kite is this: A equals 1/2 times d1 times d2, where d1 represents one diagonal and d2 represents the other. Take this kite for example. The longer diagonal is 4 units long, while the shorter diagonal is 2 units long. Plugging in these values into our formula, we get A equals 1/2 times 4 times 2. 4 times 2 is 8. 1/2 times 8 equals 4. So the area of our kite is 4 square units. This concludes our study of the unique 4-sided shapes. Remember, a kite is distinguished by having two pairs of consecutive congruent sides and having no parallel relationships between any of its sides. In all, we have examined squares, rectangles, parallelograms, rhombi, trapezoids, and finally, kites. In the next lesson, we will learn about one of the most important shapes in geometry, a shape that has no sides.